Hello everyone. Today we are going to do a quick introduction to probability. We're also going to learn some counting principles which will help us out with quickly identifying or finding probabilities. To start off, we're looking at a warm-up. Here we're being asked, what does it mean for something to be random? We use random in everyday language pretty often, but random means something different in math than it does in everyday. For example, every day you could just come up with random words like penguin or doom. And you can say that you're being random. LOL. So random. XD. But randomness is a little bit different in math. So in math, randomness is looking at situations where we can't predict the outcome of a situation. So it's unclear exactly what's going to happen in a situation. A common example is rolling a die or rolling dice. If we roll a six-sided die, we can't be sure what number is going to come up. So randomness in math is looking at predicting outcomes. For probability, we have a few vocabulary words or keywords that we use. The probability of an event, so the probability of something happening, is the number of outcomes in that event divided by the total number of outcomes. And for right now, we're looking at situations where each outcome is equally likely to occur. So a quick example at the bottom there, an outcome is a specific result, and the event is the entire set or collection of outcomes. So if we're looking at the probability of rolling a 1 or a 2 on a six-sided die, that probability is 2 out of 6, or if we simplify, 1/3. The event in this case, so what we're predicting, what our success would be, is rolling either a 1 or a 2. And the two outcomes in that event, so an outcome is one single result after the event, or after an outcome is one single result. So two outcomes are rolling a 1 or rolling a 2. Those are the two outcomes within our event. So the event is kind of like what we're studying, what we're finding the probability of. And each outcome is one of the results that could happen. So let's take a look at rolling two dice, a green die and a red die. Here we have a quick table where we have the green die up here, red die on the left. And we have a table of all the different possible outcomes that could occur rolling these two dice. So number one, how many total outcomes are there? Well, we have 6 different outcomes at the top, 3, 4, 5, 6. 6 outcomes on the left side. So overall, we have 36 total outcomes. How many outcomes result in a sum of 7? So now we're looking at a specific event. A sum of 7 would be 6 and 1, 5 and 2, 4 and 3, and then switching around those numbers for each dice or each die. So overall, we have 1, 2, 3, 4, 5, 6 total outcomes that result in a sum of 7. So the probability of rolling 2 dice and having a sum of 7 is going to be the number of outcomes in that event divided by the total number of outcomes. So 6 out of 36, which we could simplify to 1/6. So 1/6 of the time when you roll 2 dice, you'll end up with a sum of 7. It's the most common sum. So if you're playing a game like Monopoly, most often you'll be moving 7 spaces ahead. Let's take a look at a few more questions regarding rolling 2 dice. Number 1 here, probability of rolling 2 dice and the sum is 4 or less. We get a sum of 4 if we have a sum of 2, a sum of 3, or a sum of 4 diagonally. So in this case, we have 1, 2, 3, we have 6 out of 36. So again, 1/6 of the time we'll be rolling and getting a sum of 4 or less. The probability of the sum being greater than 4 is going to be all of the other outcomes here. So everything on this side of the table will end up with a sum greater than 4. So we could count those up. Another way to find this is to look at the total number of events. We have 36, and then subtract the number of events that result in a sum of 4 or less. So 30 out of 36, or 5/6. Probability of rolling a 3 on the red die, finally, is looking at the red die and the 3. So we could count all of these up. We have 6 out of 36. We could also just count on the left side. We have 1 over here out of 1, 2, 3, 4, 5, 6, 1 out of 6. So for all of these, we can add up the number of outcomes in our event and divide it by the total number of outcomes. So a few notes: all probabilities are going to be numbers between 0 and 1, and they could be 0, they could be 1. We say that an event is certain to occur if it has a probability of 1. So for example, the probability that the sun rises tomorrow, well, technically it's not guaranteed. We're going to assume that it's certain to happen. So the probability the sun rises tomorrow is 1. An event that cannot possibly occur has a probability of 0. So for example, the probability that we roll a 7 on a 6-sided die, that can't possibly happen. One quick note, just an aside, is that this is true in this direction, but a probability of 0 does not necessarily mean that something is impossible. And we'll not talk about this in this course, but in the future, you might encounter situations where we have an infinite number of outcomes. For example, you could consider all of the numbers between 0 and 1 and try and find the probability that we come up with one number out of that infinite set. In that situation, we'll get a probability of 0, but it's not an impossible event. Again, we won't talk too much about that in this class. Finally, we're going to look at some counting principles, and these will help us out with finding probabilities that have a high number of events. So it was easy enough to count all of our outcomes in the previous examples, but sometimes we'll have a lot of different outcomes. For example, if we line up 10 different people. So here we have a mouse maze, for example. We have a mouse over here at X, a mouse in the middle at Y, and then we have this ending location Z. So we can consider a few examples going from X to Y. There are 4 different paths, or 4 ways to go from X to Y. To go from Y to Z, we can see that there are 3 ways. Let's consider going from X to Z now. So going from X to Z, we could split this up into first going from X to Y here. So we have one path here. And then for this one path, we, starting at Y, have 3 different paths that we could take to get to Z. So for this one path, we have 3 different paths once we get to Y. If we look at our second path here, we get to Y, and again, we have 3 different paths we could take. And this repeats for our third and our fourth path. So one way to think about it is for each path, we have 3 different ways once we get to Y to get to Z. In other words, we have 4 paths times 3 ways for each path. So from X to Z, we have 12 different paths the mouse could take. In this situation, we can say that the number of ways to go from A, or for A to happen, for A and then B to happen. In other words, the number of ways n of A and then B is equal to the number of ways for A times the number of ways for B. So 4 times 3. We can also consider a situation where we're actually starting in the middle. So we have a mouse at Y, and then we're looking at how many ways the mouse could get to X or Z. So Y to X or Z. And here we can look at, well, from Y to X, we have 4 different paths. From Y to Z, we have 3 different paths. So we can just add up all of our paths and get 7. So from Y to X or Z, we have 7. And here we run into the situation where if we are looking for the number of ways to get to A or B, either A or B, we can just add up the number of ways to get to A and the number of ways to get to B.